Okay, the second type of polar graph we're looking at is a limacon. You can probably say it way better than me. But these are of the form r equals a plus or minus b cosine of theta, and r equals a plus or minus b sine of theta. A and b are both greater than 0. Okay, again, I'll take pictures of all these notes and post them on the classroom, but before I talk about what I wrote here in red, there are actually 4 types of limacons, and the ratio a divided by b determines what the shape is. So let me go through them, and then I will do an example of each. So your first one is just the limacon, and this happens when a over b is less than 1. It looks like this with the inner loop. This is the one we actually did in the first video. And so a plus b tells you how far right you will go, or up or down. B minus a tells you the size of that inner loop. And so I guess this actually might be a good time to talk about this. So when these are of the form cosine, okay, when it's a plus b right here, the graph is to the right of the vertical axis. When it's a minus b for cosine here, it's to the left of the vertical axis. For sine, if it was a plus b sine of theta, it would be above the horizontal axis, just like this right here. If it was a minus b sine of theta, it would be below the horizontal axis, so it would be flipped, which I actually described down here. So I didn't write out or draw out every single one of these scenarios, because I think you can easily understand like how they would flip in which direction, but that does give you a hint about which way it should go. So back to just the plain old limacon. So if a over b is less than 1, you get this shape here. Like I just mentioned, if it was a positive b, it would look like this. If you were subtracting b, it would look like that. Again, that is for the cosine of theta. It's to the left. If it was sine of theta and it was positive b, like I just said up there in the red, that's a very poor drawing of this, but this is above the, above the horizontal axis. And if it was subtracting b, this would be below the horizontal axis. Thinking if I should do the example first. Yeah, let's do the example. Okay, so the example, oh hey, this is the one we just did in my first video, but let's go through it and show you what I'm expecting you to show here. So again, like I mentioned before, I'm looking for the table. You can go through and find the zeros and the maxes, but for your theta, you will be looking at the values of 0, pi over 2, pi, 3 pi over 2, and then again at 2 pi. And think about this, because these are the values, I'm trying to have it, where your min and your maxes occur for cosine and sine. So if I take 0 and put that in for theta, you're going to get that r is 6. Pi over 2 is going to give you 2. If I put pi in for theta, you're going to get negative 2. 3 pi over 2 is going to give you 2 again, and 2 pi will bring you back to 6. Okay, so here we go. Now we're going to graph this. So when theta is 0, you are at 6. Pi over 2, you're at 2. Pi, you're at negative 2. So that would be over here, but I'm going to flip because it's a negative. That ends up right here. Where was I? An r of 2 is 3 pi over 2. So that stays right down here. And then 2 pi brings you back to 6. And so you will be, just want to make sure I draw this good for you. like that. If you're like, well, you never actually crossed the origin here, and let me explain where that comes from. If I were to find the 0 of this, 0 equals 2 plus 4 cosine of theta, you would subtract 2 and divide by 4, and so you would end up with negative 1/2 equals cosine of theta. And you're going to tell me that theta is 2 pi over 3. So this is the point 0, comma, 2 pi over 3, which does give you that value right there because you haven't moved at all. So this is what I'm looking for, your table and the graph. And you can use the hints to kind of check your work, but I do expect to see the table with your graph. This is going to be kind of a longer video, but I'll try to make it go smoothly. All right, the second type is called a cardioid, and it's called a heart because it's shaped like a heart. See that? Upside down one. This happens when your ratio A over B equals 1. Again, a hint for this one is A plus B tells you how wide it is. So, just need my notes with me here. All right, so for this one, the example we're going to look at is, if we could get off the blurriness, R equals 3 plus 3 cosine of theta. All right, so again, the values you want to pick for theta, I left myself a ton of room, joking, is 0, pi over 2, pi, 3 pi over 2, and 2 pi. Again, because those are where the max and min values happen for your cosine. All the examples I am doing are cosine, but remember sine, it's just, it looks opposite way as we talked about before. Okay, so when I put 0 into your equation there, you are going to get 6, 3 plus 3. Pi over 2 is just going to give you 3. Pi is going to give you 0. 3 pi over 2 will give you 3. And 2 pi will give you 6. So again, you are welcome to check those numbers. I'm trying to make this go a little bit faster here. So now I'm going to plot them. Again, this is the polar plane, but I'm not drawing in the circles, same as up here, because all of these points end up being on one of the poles, one of the axes, to make my graph a little bit more smooth. So, but if you have the polar graph paper, awesome, and use it. But just if you're like, why is she now graphing like this? There's the answer to that. Okay, so 6, 0 is right here. Then we have pi over 2 with an R of 3, so that's right here. And then pi is at 0. So you actually found in your table one of your intercepts this time. 3 pi over 2 is at 3, so that's going to stay there. It's not going to flip. And then 2 pi brings us back to 6. So again, this is important that you know the difference between the shapes. When are you supposed to have the loop? When is it going to look like a heart like this? Then we get to more dimple, all these two other ones we haven't even talked about yet. So you need to know what the shape of these actually are. So again, this one's going to come up like this. Again, it's a sketch of this, and people always ask, well, how far out am I supposed to go? Are you going to take off? You know, I mean, if you make it a little ridiculous, that's not going to work too well. Again, it's just a sketch. Can you get what the key points and what they look like? The third type, remember these are all called limacons, is the dimpled limason, and that happens when 1 is less than the ratio A over B, which is less than 2. A hint for this one, again, is A plus B tells you how wide, but from the pole. And some people actually call this one the bean. I guess I'll add that one in. Again, this one's going to dip below the axis this time. Okay, and here I go again, my table. I'm picking the same values again because those tell me the max and min values of your cosine. Okay, and the 0 actually as well. I haven't been adding that to the list of every time I say that. Okay, so if I put, my equation, is R equals 3 plus 2 cosine of theta. All right, so here I go. When I put 0 into the equation, this time you're going to get 5, finally a new number. Pi over 2 is going to give you 3. Pi will give you 1. 3 pi over 2 will give you 3. and 2 pi will give you 5. Okay, so here we go. We have 0 is, these are all radians, is at 5. Pi over 2 is at 3. Pi is going to be at 1, so this time I will have a dot there. 3 pi over 2 is at 3, so it stays down here, and then we come full, technically circle again. So again, this is the bean shape. It has a little bit less, less pronounced of a dip. Okay, so make sure you show that in your graph. Let's see how well I can do it. You can laugh at me. It's pretty good. Okay, things to notice, remember A plus B is how wide it is from the pole. So your A and your B, sorry, are 3 and 2. So from your pole, 3 plus 2 is 5. That's a distance of 5. This right here, you're at -1. Notice that 3 and 2 differ by 1, so you're going to be at -1 over here. Just as pop over here to my other notes, I didn't do this example for you, but say you had this one here, it's still the bean example, just to show you what that graph would look like. 7 plus 5 from the pole is 12. If you actually made your graph, your table, you'd end up 12, 0. And then 7 and 5 differ by 2, so it will hit over here at -2. So I think that's a good just other example to show you really quickly. Okay, and then the last type of limacon, remember that we're looking at here, is your convex limacon. Isn't this so exciting? Okay, so this happens when A divided by B is greater than or equal to 2. I'm sorry for the lack of enthusiasm. I am multitasking with my children and making math videos. It's always exciting over here. All right, so hints. A minus B is where your flat part hits. So flat part, we're talking about here. And A plus B is your width, where the large end hits. So the example we're looking at this time is R equals 4 plus 2 cosine of theta. Again, we're choosing the same values because those give you the max and mins. And most of the time, well, it gives you where the cosine and sine are 0. Okay. Okay. All right, so if I put 0 in to this equation, you will get 6. Pi over 2 is going to give you 4. Again, you can go back and try these on your own for the sake of this video that's now probably like over 10 minutes long. 3 pi over 2 is 4, and 2 pi is going to give you 6. So here I go plotting this. 6, 0 radians. Pi over 2 is at 4. Pi is at 2, so you will be out here. No flipping because it's not negative. 3 pi over 2 is at just 4, and then 2 pi brings you back again. So again, you need to recognize the equation and what's going on with A and B and what the shape's going to look like, because I mean this looks very similar to the last one we just did. You need to know the difference between the dimpled and the flat. So again, let's see how well I can do this. It's going to be flatter here. No dimpled, similar to egg-shaped. Okay, again, the hints, A minus B, where the flat part hits. What the heck does that mean? Well, A minus B, that's a 2, and that we mean you're over here at -2. That's where the flat part hits. A plus B is the width, where the large end hits. So from your pole out to here, that's your 6. 4 plus 2 gives you 6. So again, this is all about just the second type of limacons.